Okay. So, I think we're in a good place. I wasn't going to stream today, but I think I'm going to accomplish some cool stuff today, so I'm excited to get back into it. I think we're pretty much just picking up where we left off from yesterday. So, we've already built this. So, we've already rebuilt the Godot C++ extension. So, that's done. In fact, what I want to do, real quick, is I'm calling this done. Squashing and merging, done. Put a pin in it. Already too many code changes to begin with. 43 file changes. It's too much. So that's fine. So we got that, and then, yeah, because I already pushed up everything. Let's delete that branch. And we're in a good place. I mean, I think there's like one or two little bugs, but nothing crazy. Git branch -d. Cool. So, what are we going to be doing then? I think now what we're doing is improving OCR quality with OpenCV. Like, that's literally what we're doing today. And let's see. Save debug images again. Yep, got that working. Run test case images. Yes, and I got it so that it'll run multiple. I think that's the one thing I fixed off camera was I got it so it'll run all the test cases. I figured out where that bug was. Error on bad OCR. We basically have that there, but I'm going to do a little bit more with the test case. I'm going to do error on slow performance. And I can't really make the test case like fail, at least not easily right now. But at least I can make the test case yell loudly. Fix alignment regression. Yeah, that'll be the thing. That'll be the one thing we work on. So now that I'll have the test running where it'll report on both. Let's call it OCR quality, where it'll report on both of these things. So that shouldn't take long at all. Get that in there. And then once I have that, where I'm getting a nice report from the tests that run, then I'm going to experiment with bringing back some of this old code that was sitting around, that for the older version of the method, to see if that improves. I expect it'll improve quality, but reduce performance. So at least I want to see what that looks like and compare the results. And then I think I already have deskew logic ready to go. I think that's what I was looking in my code for dewarp, and I remember I never implemented dewarp. I found a library that does. And then, so then the question is, can I use that library? Can I port it over? Maybe it's like, I think I might have to rewrite it in OpenCV. But either way, I think I could start with I think I have deskew somewhere. So fix this, see how that improves things, and then possibly decide to do dewarp, or at least take a stab at dewarp. But still, I think my goal is, after today, be done with C++ for a bit and get back to GD script and Godot. So that's what we are doing. And we'll run that in the background. Yeah, so to show you what that looks like, stretched out a bit too much. Still too much. There we go. Ooh, didn't want that. There we go. Yeah, so you can see that here's like a test report. No, score too low. In this case, it scored a 0. And why did it score a 0? Because I think this is probably the last test that we ran. Is it this one? Yeah, so this one, you can see the images drift too much. So these are the 5 input images. Here ends up being the template. This one's way off. This one's way off. We end up with... Actually, no, this one... No, I think this one is the one that scores meh, because we only end up getting like 1 out of it. But I think the one that scored 0, so that one scores like 20%. This one... has terrible alignment, and so you can see it's just horrendous. Actually, the best way to see it is up here. So you can see how much the different pages are off. And the pages aren't that bad. I mean, if we look at these, like you'd think they would be similar enough. So this one, template, good alignment, good alignment. It said all these were good alignment, and so is this one. So you'd think we'd be able to take these 4 images, compared to the template, shift them, and get something that doesn't look like this. So the alignment logic's wrong. So the question, and I think this is the one that's scored a 0. The other one scored like a 20%. This one's scoring like a 20%. And I think that's just because error, 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 error. So then when we average it, we just end up effectively copying the same image. So it's just OCRing the same image, which we already know when you OCR a still frame from a video feed, it's really hard. Like I can tell that that's the word wherever anything is left out, I think. But Tesseract can't do that. We need at least one other image to merge to get some decent quality. So this one, I don't think there's anything that can be done about this. This one's going to score a 20%. I think that's the reality. This one, the aligned frames though, that test case, I think we can improve. So let's get into it. I think for this, we actually dive into Godot. So I want to get the test cases up, get them running the way I want them running, and then I'm going to start tweaking lots of OpenCV code. That's what I'm doing. In addition to sips of coffee on this lovely Thursday morning. Here we go. Load. All right. Interesting. I want to see, since we switch back to main. Okay. Yeah, I feel like especially these like .uuid files. This one I didn't commit just because I'm throwing away this file anyway, so why bother committing it? I don't know. I feel like, or like there was like .import files or something. Yeah, they kept being really annoying. I think yeah, I don't know what was going on with them. Let me nuke. What do we have here? Is there anything useful? Nah. We can nuke all but the last test. Okay, skip. Cancel. Weird. And then this one, we'll delete that one. So here we go. Debug HUD. I think we just need the test results. I think to keep it simple, what I'm going to do, what does the test report look like? I want it to be readable. So where is that coming from? Oh, because it's too long? Oh, because the /n. That's fine, because it's going to be its own line. Okay, so I think test report, I think I can keep this as is. So can I record speed? So how are we going to record speed? So I think we do, I don't want to do this. I think we keep this simple and we just do game state dot log, and we just do I'll just call it score. Why not? And we'll just do score. And then here, and then we'll do time. And I don't know, I'll just stub it out for now. Var runtime int equals 0. Fine. And then what I'll do is take this Yeah, here was that fix for the tests not continuing after the first test. So it seems like we would finish the first test and immediately try to set the images. We'd load the images, set the images, and trigger a scan. And I guess it's fast enough that the background thread wouldn't be done with its cleanup from its prior work, maybe. And so we would just hang because this trigger would occur just too soon. So I think, who knows, we might not even need a 1 second timeout, but adding a second here seemed to resolve it. This is for running tests. I don't care about waiting a second between each test. Not until we have 500 tests. Which hopefully will never happen. All right, so let me take this. So that's going to be I'll just do a little mini test report per test. That way if I'm looking at an individual test, I can quickly see what's going on with it. But then, if we are done running tests, final report, and cleanup. There we go. Now, for the final report, I think I'll bring this in. We'll call it final test report. Keep it simple, nothing crazy. And then what I'll do is, here we go. Here's what we'll do. You know what? I'm going to bring this back. Bring this back up. If test.score is less than target score, or runtime is less than target runtime, we don't have a target runtime yet. Let's just hard code that for now. And actually it's going to be longer than. So we'll say if it took longer than the target runtime, then instead of, we're going to do var successful tests. I was thinking about, I could do this as like a JSON object and then loop through it, and let's just keep it simple. We'll do this as an array of string. Oops. String. And we'll initialize it to that. And then var fail tests is an array of string as well. Cool. So then what we'll do, and then we will do fail tests.append, and I got these backward. And we'll just do test report. And so what we'll do here is var test report is a string, and it's going to be nothing for another moment. We'll do we have a test name? First run results. Hold on. Run next test. So we pop it. All right, we could just do current test just so we have it. Yeah, so we'll just do var current test. Current test case. Make it a string. Sure, and we'll just start it as empty string. I think we can do that. And then there. Right? So what we'll do then is we will, so it'll start by being blank anyway. We will then pop it off if we've got it. Then we trigger a new test. But this will be set until we start a new one. So when we're done with that test, yeah, this will work. All right, so our test report is going to be current test case plus, I don't know. Well, this will all change later. And we'll do string score plus do we have the runtime? There. That's our test report. So we'll add it to the failed tests, or we'll add it to the successful tests. This is what a report line looks like. And then down here, we'll do for test in failed tests. We'll call it test report here, and we'll drop that there. This has to be a string, since I have typing enforcement turned on. Cool. And then, what is it, successful tests? Yeah. We'll do successful tests first, and then we'll put a break in between them. Oh. There we go. Actually, we will do this. And then we'll hear, and then I will do a /n. I don't know. This looks ugly to me, but it's fine. How does it look when I run it? So there's our first test report. We get a score and a time. There we go. So then we have our final test report, our test report for this one, which got a score of 0 and a time of 0. We probably should have the name here. Let's do that. Do a paren. Didn't ask for a closing paren, thank you very much. And we'll do current test case. And then we'll do a closing paren. Okay, so then we would end up with test report for the test case name, which is super helpful then to know like how we did. And then the successful tests are empty. I don't think it hurts to have an extra /n here, just to help with the readability a little bit. So here I can see nothing succeeded, both of these failed. Here's the name, here is the other name. And yeah, I can see, oh, that one got 0. Is that true? So it's saying this scored a 0. Well, that's a little surprising. Whereas this one is the one that scored a 20. How? Maybe because up here it was able to pull out some words? That's crazy. Huh. Well, what did the first test come back with? A bunch of... Well, okay, fine. So it somehow saw a bunch of gibberish. And I guess this gibberish is enough to give it a score of 20%. Okay. Whereas this one came back with nothing, and that's, of course, going to score 0. So it couldn't find any text in the second one. All right, so now measuring time. I could keep that simple. Yeah, let's keep it simple. Not do anything on the C++ side. Well, I don't know. Could I do that? Let's see. Because we just have our main loop. And in the main loop, where are we? Yeah, so this is the main loop. I could add a start and a stop, and then report that. But right now we just have one signal. Hold on. I think I might have to sneeze. We just have the signal text. I don't want to create a second signal. I don't want to create a second variable, have it go fetch a thing. Again, let's keep all the test code, testing related stuff as much as possible here. So fine. Let's do... Godot measure time duration. Elapsed time, yeah. Okay. So let's go with that. We'll do run next test. I guess we start that. Yeah, run next test is getting a little bit big. We'll load images. I guess we'll start it here, right? We'll do var time. This is not a string. What is it? Oh, os dot get. Yeah, time is not a thing there. This must be old. 2020. The time elapsed in milliseconds. Got you. Right. Okay. I did hear about this before. Okay, and that is probably an integer, right? Huh? How is that not? Get static. Get what? Oh, time. Time. Right. Not OS. Time. Okay. Fine. There we go. It's an integer. All right. So then we can put this here. Time start. And where was I? Okay, so we do time start here. So then that is going to be the beginning of things when the moment we do the trigger, basically. And then if it's not the first run, then we get here. And let's get our runtime. Let's get it immediately. So var end time is going to be an int. And I guess I can measure this in terms of milliseconds because, I mean, ideally I'm going to boost performance to the point where we're below 10 seconds. So that means like 9,000 milliseconds or less. I can live with that. Let's go with what was that? Time start. Let's do start time. Let's do time. Let's call it a timer. Start timer. There we go. And then this is the end timer. And we'll just do end timer minus start timer, and that's our runtime. Okay. Let's say our target's 9,000. Not that it's going to matter because they're both going to fail anyway for a quality check, but just so we can see it. And also because we're writing debug images, that's going to hurt performance, which is going to throw off our numbers. And okay, fine. Okay, that one said 9.5. Also because this is running on Windows, because this is running on a Windows machine, things are going to be much faster than they would on the VR headset. I got to remember that. So, you know, one of them took 9.5 seconds, right? Is that accurate? Let's measure that. So this said 9.5 seconds. How did we start things? Here it is. So basically 39.8. So 39.8 to 49.3. So under 10 seconds. And there we go. 9.5. 9.5 seconds to do the whole thing. I'm a little surprised. It's faster than I thought, than what I was experiencing. Yeah, this said text similarity 20%. And then we got a double space here. Very nice. So that's a good test report. I like that. I can live with that for now. That tells me as much as I need to know. And then if I come down to the second one, got back nothing. No similarity. And then, yeah. And then our final report is this. So for the final report, I wonder, I know in like Python has this. I assume Godot does not. But in Python, you can actually do tricky things where, depending on how you write this log, you can force it to have the amount of space here that would kick it over to here, so you can have nice, distinct columns of your results. I can cheat, though, and I can just reverse it for now, since I'm lazy. So, where are we? Yeah, we can change this to a vertical pipe. Change that as well, and then we will pull this over to the front. There. And then what I can do is we can do score and then time in milliseconds, and then test name. And how does that look? All this is in service of just helping me to test faster going forward. The times do have some swings there, right? That took 8.7 this time, so that was quite a bit faster. Right. Yeah, I mean, that worked. So I might as well just give it a little space. And then the time one probably as well. All right, that's fine. Just to align them slightly better, give them a little more of a gap. I don't think it's going to matter. I can live with that. So now I got to actually properly report on successes and failures. So I am noticing noise here then. That was faster this time. I don't know what this one was, whether that was faster or not. My brain, of course, jumps to the over-engineered approach. Like, should I keep track of a log file of all the past runs and what their scores were and what their times were and then average them and whatever, specifically on the time front? And then you go off of that, like min-max it or something like that. I think I can just draw a line in the sand and just say, look, if it goes beyond that line, it's a canary. Scream about it. This is annoying, though, because it does mean, I don't know, based on the CPU cycles or whatever, things may take longer or faster. It's also writing files to the file system. That's the problem with doing it. Well, actually, I should be able to turn off file system writing, right? So, because right now I'm just constantly writing files. So that's a thing, isn't it? Where am I? Scanner service. Is debug. If I do is debug false, what is that going to do? Let me remind myself. Because I know some of this I just have hard-coded in the C++ for now because I couldn't get it working the way I wanted. So, debug mode, where are you used? Trigger scan only works in debug mode. And then we only wait for the trigger if we're in debug mode. Okay. What about... So, let me undo that. I don't want it running in production mode for when I run the tests. For here... Oh, yeah, save debug image. Is debug files enabled? Oh, I think that's just in the .h, right? Which... So debug files enables is false. So we shouldn't be writing any of them. Unless I am calling set debug files from somewhere. Don't think I'm calling it from... Okay, so I'm setting that here to if we're on debug. Got you. So we could make this a quick change. And for now, just pass it through. And then I need to change this at the top, so start scanning. debug files, and then in the .h, where's our start scanning? We'll do debug files here as well, and we'll default to false. Happy, happy. Let's just do a .build all. Let that run for a second, and then over here on Godot, debug files bool is false. Let's set that. So now I can do that. Did our build finish? No. Wow, Android took that long? It's weird. Yeah. Now, Godot typically doesn't detect it right away. I don't think I need to do this because I'm just running the command line. But let's reload it anyway. Just sizing up something. There we go. Okay, and then here we can test skip. And now we're skipping file writing. Whoa, things went a lot faster. Okay. Wow, that was fast. And did I write any files? What was it 1054? So no, we didn't. We skipped the entire file writing. Amazing. And things went pretty fast, actually. I think a score of 0 is less likely, so let's back that off a touch. Wait, no. Debug HUD. Go back 1 on that. So that we'll get that to align except for 0 scenarios. And then actually let's move it over to there. Because that'll bump that in and then this will bump over a little bit. There. Just a little bit of OCD. Just a touch, just a hair. Okay. What am I thinking now? So I made it faster. Can I... This is still stuck in main. I don't like that. Right? Isn't that where I put it? Am I crazy? Where was I? Oh yeah, here we go. I'd rather this be set from somewhere else and then get picked up. I don't know. I guess I'm also still likely going to call this scene directly. And if I call it directly, then it shouldn't matter. Yeah, I'll worry about this later. Or again, be able to at least pass some sort of flag from the command line so that I can use that to determine things. Okay, now I do want to control this so I can say what is a good score, because there are some tests where, you know, it's never going to get a good score, but its time should always be fast type thing. And so I could do that in our test cases. I could store a little file here, a little JSON file, and read it per test. Or I could do an individual file somewhere. And then that way, if I need to tweak any of them, yeah, let's do it as an individual file somewhere, because one, that means I only have to load it once. And then two, I mean, I could see a scenario where if I boost performance, you know, then I would want to go update every test, and I don't want to have to go update 20 files. Okay, so how do I want to do that? Godot read JSON file. Okay, so we do have this. Okay, let's come in here, and we have our run next test. We should build test case list, which is going to come through here. Well, I don't need to care. I just need a lookup table for this. So I could just call a init test result. I don't know, scorekeeper, whatever. Let's do that. And let's do that. Var JSON string. Call it JSON data, because we don't need to have its type in its name. And that is going to be, it's not going to be string, right? It's going to be whatever. Really? Huh. I'm suspicious. Alright, I think maybe we need to do this. And then we'll do json.parse. This isn't a string, right? Can I assign value JSON? Yeah, so it's the type is JSON. Can I assign a value of type error? JSON.parse JSON string. JSON.data. Ah, okay. Okay, if, right, this is just error equals, okay. I love how they do that, error, like, call it error, but the error could be okay. Like, this doesn't read right to me. I would think this would just be, like, parse result is okay, or something like that. Calling error, if error is okay. We'll do var data JSON equals JSON.data. Is that true? It is a string, but it's not. Type array. Unexpected data. Prints the array. Is that a type? It's just a property. It's a variant, so it can be whatever it needs to be. Can I do a dictionary? I don't know. This is already getting annoying. Yeah. Where are we doing with the load files, right? Load files, file path. That's just image.load. I have load debug images. Right, so that is just going to be our folder. Build test cases. Again, this is from 2021. 4.x as file has been renamed and parse JSON does not exist anymore. I love these like very fast updates. Interesting. So I'll give this a shot. Why not? No, but it doesn't return that. No, it returns a dictionary, right? Oh, used space character. Also returns dictionary. This is a type string, I think. File path is a type string. File access.open returns file access, probably. That returns a string. And this is a dictionary. So in theory, that works. Maybe I should do, let's comment this out. We'll do load expected test results. That's really what this is. And we'll do that. And I don't need the path because I already have it. It's the test cases dir. And this had director access to it, so we'll do plus on that. Okay, that had a slash on it. So we'll do we'll call it expected test results .json. All right, so now I know what my file is going to be called. Let's do here vim testing. Those are test cases. Okay, and then I'll just do a simple dictionary. And then within that dictionary, we'll do our test. This is not the right way to do JSON, but we'll do we'll do it this way, because you're not supposed to. It's valid JSON, but it's not proper JSON to have like a key in a dictionary to be, let's say, a line frames, because that's not something you can iterate over. Like there would be no iterable for it. Like technically what you would do is you would have something like test cases. You know, you do something like this. You would do test cases, and that is a list. Whatever. And then for each test case, so this would be an array of dictionaries, and then in each dictionary you then have like a name, and then that would be like the name of test, right? And so that way you could iterate over all the test cases, right? You're then looping. Technically, a JSON object could be an array. You don't have to start with it as like this dictionary type thing. Technically, valid JSON, and you'll see sometimes it'll start as an array. It'll immediately be an array of objects. But I've seen parsers struggle with that. Like I've seen that fail. You know what? I want to be proper. Let's be proper. I've already started coding it, right? So let's keep going. All right. So in this case, then, we have that. We have our name. Wow, the indentation here on this. Fine. Let's do that. Okay, fine. So we have name, score, and we'll say, I don't know, 20. And then we'll have time. I don't know, 4,000. 1,000. 2000. And what do we have here? We've got align frames. Okay. So then I would just duplicate this. And then one thing I'm missing is a comma there. And we've got crop page 1, crop page 2. So those are our two test cases. I can't remember how one of them scored. I think this one scored a 0, right? Fine. I'll keep this here for a second. So then we would load the file, get the file as text. We then call parse JSON on it. I don't know why you need that as its own call when you could just call it directly. I don't know, we'll call it expected test results. Okay. And then we'll do for test case, which is a dictionary, in here. Right. Sorry. In fine. That is going to be this, right? Actually, I don't even need to do a for loop. What am I doing here? Like this, I'm still in Vim mode. My brain can't get out of Vim mode. This is going to return void because we don't care. We are going to do this up here. We'll get rid of these two. And that should throw a nice little error somewhere. So I'll just do yeah, see, I hate this. Fine, let's do it the inappropriate but easier to access way. It's not valid, it's not proper. But it'll work. So the bad way to do it, which I'm going to do it the bad way, would be to do it like this. And then now it's just a simple lookup table. Again, technically you shouldn't do this, but I'm going to do it anyway. Okay, so then I would just do, yeah, so then Vim mode in my brain. There we go. So now that's it. There's the whole thing there. I don't need a file path here. Here, so now we've got this. So what we can do is var target score, which is an int, equals current test case score. That should work, right? Copy that. And then we'll do target runtime. Do time. There we go. Now we have our lookup table. That should work. Let's run it and see what error we get. So if I run that, hey, look, one of them succeeded and one of them failed. So if I do cat testing test cases expected JSON, is this true? So we have the test case, the second one, score is 0. Well, we expected the score to be 0, so that's fine. And the time took less than 2 seconds, so it passed. And then the other one, the score was fine, 20, but it took longer than 2 seconds. And so we failed the test. Fantastic. I love it. Okay. So if I go edit that, I think for align frames, we'll let it go. Well, first off, let's fail all the tests, but let's keep it, let's go to 3 seconds for align frames. And then let's up our expectation to 40, and let's up this one to 20. So now they'll both just fail all the time. And now we can go fix that. So if I go edit my things here, now we got it. So we've got erroring on bad quality. We've got erroring on slow performance. Now let's go experiment with that alignment regression change. See, it didn't take that long. It only took like an hour. And yeah, now I have here this dictionary in my test cases, and I can always edit it in one file. I might change the approach later, but that's fine. So if I go look at the refactor here, I think it was, let's search here, align. Yeah, so this is work with downscale images for faster. So let's call this one fast. Let's do that. Let's add a private. Cool. So there's a line image fast. And then if I go to the refactor, I think this is right? Yeah, this one doesn't do that. So let's bring that back over. Let's get rid of this. I don't need to know the how. and then I can close that. There we go. So what did we end up with? 1 second and about 3 seconds. Let's not skip. We'll run tests. We'll do the build. Wow. So, was it 1 second and 3 seconds? I'm a little surprised because here, what if I run it again? We do a skip. Also, by the way, let's turn off. Let's do debug files so I can see what's happening. Because this, I didn't expect this to get faster, and I didn't expect this score to go down. So that's curious. Let's get over to test results. And yeah, we got our first test result. Yeah, since we stopped recording them. Good. So that's working as expected. Again, score 12. So it did worse, actually. I'm a little surprised. And it's taking a lot longer. Wow. Okay, but now this time it took... Something went fast there for some reason. 16 seconds. Wow. Okay. So that is, like, noticeably faster. Let's take a look. And which one is it? Align frames did worse on its scoring. Oh, but I can't. I don't have the debug images. That's annoying. Okay, so it did worse because it actually tried to align them. Is the problem. So that's why it went down. What I should do is record a new, because like I can, I should record a new set of images for like a new test case. I mean, there is drift there, but like, I would have thought it should be able to align those properly. One thing I'm missing here is writing out the images. So this is too dissimilar. Yeah, okay. Let me just take a moment and do this. Sit up a little bit. Okay. Oh, interesting. Was that in the catch? Yeah, it was inside the double nested try except. Okay. And then we have the low correlation. Oops. There's low correlation, and then translation issues. Translation too large. This is why it's not searching properly. It has space in it. Okay, translation too large. And then finally we have like good alignment. There we are. Okay, so the final one we'll just do here, which is good alignment. For these other ones, oh, and of course the time took a lot longer because I'm saving images now. So that's I can't go off the performance. Ignore the performance, of course. When you're that's of course the golden rule that I've been trying to follow, and my brain keeps getting distracted. If I'm working on quality, ignore performance. If I'm working on performance, ignore quality. And that's true of like this debugging as well. So first start with try to get the quality up. And if the quality is looking good, then turn off image writing and run the test again. And that's when I should see the quality still good, but then what's the speed performance metrics? Alignment quality low. And then let's do large scale change. And then this is large rotation. And let me get it file name approved. Okay. Let me run it again. No skipping this time because I need to rebuild. Anecdotally, I'm going to say the quality got better. Even though it looks worse. We're in such bad quality territory that you can't really trust the metrics just yet. Not until I see like a boost up to like 60% plus. Then we can start nitpicking about a few percentage changes. Where's the folder? Okay, so here's the results then. So there was our template. This said alignment quality was low. This one said good alignment. And yeah, you'd think there should be good alignment. Alignment quality low, too dissimilar. So it was really 2 images total. But it doesn't look like we actually aligned them. It looks like it literally did nothing to align them. So did we skip a step? Where is aligned? Apply transformation. We did a final quality check, huh? So we did a grayscale image of the aligned. And we computed a final result. And it said that we had the correlation. Alignment quality low. If it's less than 0.6. So what does that mean? Which test case is this, by the way? This is the align frames. How did the other one do, by the way? Again, template, too dissimilar, too dissimilar, too dissimilar, too dissimilar. And then we end up averaging just like the one we've got. And that should have scored us a 0. And it did. So it's really this one, which we should see. This is one where, yeah, okay, let's just take a moment here. Because if it can handle this case, where, like, first off, it said this one had good alignment, so why didn't it align it? So let's fix that. Yeah, and then when we average it, you know, here's the other problem that I see. Notice how when we average it, I did a little cheat, and I don't think that paid off. So if we do what? Align image. I think that maybe gets called from down lower. Here we go. So I keep returning, if it fails to align, I return the template image. And so then align frames gets pushed back, and then we average those frames, which is a simple thing. I think the one problem I'm seeing here, which is it's not a problem just yet, but notice here when we averaged them, notice how this is quite crisp and clear, but then we've got this shadow here. And the reason why is because we're still averaging 5 images. It's just that 4 of the images are the exact same image, because when we came across a bad image, instead of throwing it out of the list, we actually, hold on, and let's ban you. There you go. instead of chucking it out of the list and then just averaging the 2 frames that we have, which in this case would have made things worse, right? Because since the alignment's bad, these lines would be unreadable if we truly average them. But instead, that final image, like it's like 4/5 of the image end up being the template, and 1/5 ends up being the other one that we found, and we don't want that. In this case, it would actually make things worse. But if we can, let me fix this alignment, see if we can. And then that would put us, that's going to be important because that would put us in a place where, hey, if we do throw out, we're going to, 5 images, the template will keep, so there's 4 others. Of those 4, if we throw away 3 of them, and we end up with just 2 images to merge, well, those images should be 50-50. We should take half the data from both. And I think that would greatly boost quality as well, and probably boost speed. So let me go to the tracker here. So merge multiple frames. So this already works kind of mostly. True. See how the quality is after we have cropping working. Yep. We should auto crop all the images after we know what the bounding box is. Yep. Then tune this to see how many frames we actually need to get good result. Or does the step need to happen sooner? What happens if we do the step later? Right, so that's just ordering of when we do it. Okay, so to do for improvements. Let's just keep track of this here, and we'll do a to-do list. So throw out frames that don't align. Right now we use template, which diminishes other frames, other good frames. Good alignment frames aren't getting aligned properly. All right, let me take a moment and ask. Let's phone a friend and just see off the top of its head. What it sees here. So we have a line image. And this just speeds us up. And I don't know, it still feels like cheating to use AIs for help. Like in my heart, it feels like cheating. But it does speed things up, because if nothing else, it can eliminate all the obvious stuff and let me get quickly to the meat of the problem, and then I can switch on my brain and actually solve the problem. Below is a C++ function in a GD extension for Godot 4.5. Right now, I'm investigating a bug where frames that, quote, that have, quote, good alignment don't end up getting aligned well at all. The end result is a, yeah. Can you help me figure out why that might be happening? And what settings, and what code or settings changes might be needed to fix this? Code for reference. can see several potential issues that could cause frames marked as good alignment to actually be poorly aligned. Here are the main problems and solutions. I should have told it not to rewrite the whole method. I don't want you rewriting the method. I want you to just make your observations and just tell me specific lines to change. The main problems identified in your code are wrong return value on failures. Your original code returns a reference when alignment fails, but it should return to align, the original unaligned image. This is confusing because you're essentially replacing the current frame with the older reference frame. Yeah, I'm doing that so it aligns correctly. Warp inverse map flag issue. The most critical bug is using this flag inverts the transformation matrix, which means your aligned image is actually being transformed in the opposite direction. Okay, that's cool. Really? I mean, let's be fair here. This code was mostly written by AI. All right. Both versions, in fact, have that. Where are we on this? So that's the final quality check. Oh, here we go. So you're saying to do this instead. And yeah. I don't know why this is wrapped onto its own line. So you're saying just doing that is going to boost things. Well, let's see. Can we go from 12 seconds to above 20? Not 12 seconds. A score of 12% similarity. I mean, the reality is, if it works, it'll be very obvious because we'll go from like 12, 20% to like 80%, I imagine, very quickly. Score of 3. So we got worse. Nice. Just do the opposite of everything you're doing, and then everything will get better, right? All right, what do we got? Low quality. Wait, what? I thought it was alignment quality low, too dissimilar. It's the other one, right? I keep clicking on the wrong thing. Wait, now we're throwing it out altogether. I literally ran it the same exact way. Why would the logic produce two different results? Oh, did we end up throwing it out this time? Hold on, because this was, if we go back, good alignment. So we have our template, and then the second one in, it said it had good alignment. And that's on aligned frames. Yeah, okay, so I'm not crazy. Alignment quality low. Well, that's not right. And all I changed was this one line of code. So let's get building and run it again. Maybe it's just like a little finicky and based on how the CPU does things for the moment. Still says alignment quality low. Well, that's cute. And that's why our score went down to 3. Seriously, this is annoying. Let's run it again. Like, how am I not... Like, the whole point of writing a test suite like this is these things should be mathematically reproducible. It's the same image. It's the same operation. Why wouldn't it produce the same result? Quite confusing. Huh. I didn't have like a... Oh wait, alignment quality low. Is there 2 different alignment quality lows? 2 dissimilar. No, okay, so maybe... Alignment failed. Okay, no. So now we're throwing it out. But that doesn't make sense. See, if this was sending it too much in the wrong direction, then... Huh. One thing I want to do is... Where's our test cases? Nope, not where I want to be. Here we are. Build test cases. Filter. Let's go with specific test. And the specific test we're going to go for is align frames. Yeah, out of laziness, I'll do it this way. We'll just do that, and then we'll do specific test. And we'll pass that in that way. If filter, we'll do if specific test, and then if test name equals specific test. Then we add it. Then we'll do elif filter. So if we have a specific test, then I could make this even smarter, right? Like I could do, you know, pass in a star or something, and if there's a star in there, then we know it's a filter or something like that. If it's specific test, then only use that test. Otherwise, if it's a filter, filter down. Otherwise, append everything. And right now, I just want to run align frames, so that's our specific test. What else did the AI say? What's up, Claude? The most critical bug is using this flag inverts the which means your aligned image is actually being transformed in the opposite direction. Remove this flag to fix the alignment. Your final quality check uses template matching on the entire image, which can be misleading. I've added a normalized check as an additional quality metric. When saving debug images for quality assessment, save the aligned result rather than the original to align image, so you can actually see what the alignment produced. Okay. So final quality check. So we have the aligned color, final result, TM coefficient. I don't know what that is. Normalized. Why is that abbreviated? Why not just spell it out? Match template, ref gray, aligned, final result. We have doubles, min max. All right, so it's saying and why not make this an alternative? Alternative comparison check. Let's go with that. So it says if final max is less than 0.6 or normalize is above 0.1. Then we log. So match is that, MSC is the other one. Mean square error, right? And then for our final log, I think you just add this in the middle. Okay, so we have correlation, final match, and MSE, translation, rotation. Okay, so that's all that got changed. One thing I'm gonna do is I'm gonna change this, and let's get rid of the clear for the moment. So that way I can see the results. So we'll run test with a build. Yeah, and I think I'll probably just build every time now for the moment because I'm going to be making quick code changes. And this is amazing now. Now that, I mean, I know it may have seemed tedious to build out this entire test suite over the last couple days, but now this means I can test so much faster. So instead of having to build for both Windows and Android, then export from Godot onto the VR headset, put the VR headset on, instead of having to do any of that, I can just run a single command and then see what the result is. So what I care about is up here somewhere. Do I not have... Oh yeah, here we go. And now I should actually see just the one test. Okay, sorry, it said the alignment quality was too low, but this would be on the second one in. So not this one. It would be this one, right? Because then we do the debug image save. Right, so... Yeah, so we returned early because we're saying that our match is 0.25. MSE, if it's greater than 0.1. Darn it. If it's greater than 0.1, which it's not. Okay, so here's what I care about. Let me just steal this report. I mean, I guess I can have two windows open, right? There's no reason why I can't. A/B testing them. Let's do that. So let's flip back. Test.sh, right? And let's do here, and we'll do there. So now we're literally A/B testing in some ways. Okay, so this one over here is the old. This is the new. Well, in many ways, this is the old because this is the previous version of how this thing was running. Yeah, and as we can see, it scored 12, so it actually scored better. Yeah, and so then on frame 1, over here it said it was too low, matched 0.25. Over here it said it successfully aligned it. In fact, it even got past the mean square error, because the mean square, yeah, still stayed low. So this seems to indicate that this was actually a good thing. So for here, yeah, what if we wrote the other image instead, right? So we did alignment, match template is a final result. What does this do? Finds the global minimum maximum in an array. But it returns void? I don't understand what that does. I guess it sets these values to min-max, right? Why do I keep right-clicking? So we don't use the min value, we just care about the max. Gotcha. So we're computing a distance here. And then here we have our reference gray, aligned gray. We have our diff. Get absolute diff. Okay. So, yeah, that's... mean square error. Normalize it. Okay. This is fine. What I'm going to do is... let's try writing this out. actually, let's do then test. Since I am doing, let's do clears again. Since I'm doing like more of a different approach here. Okay, so this is the old, and then I'll queue this up. So this is the new. Oops, let's not. Let's kill that, sorry. Let's actually give it a second to build before I accidentally trick myself into thinking something's happening a certain way when it's not. Give that a moment. Okay, now we can come in here. Is there an error? Oh, that's whatever that error is. Save that, and then now we'll do this build. So then over here, all right, so we scored 12. Oh, yeah. Yeah. So what I want to see is I want to actually look at this. What did we write out in that case? Okay, so that is not even a... Darn. Okay. I hoped that we were able to write out like an image that represented something. It's a mat, but it's not really a useful mat. What did I do wrong? Yeah, so final result here is it's a matching thing, but it's not really. What I want, what do I really want? I want a line image. I need to see like what the result would be. So line frames, we average the frames. Right, so let's go. So in this scenario where, I mean, those are ones where we're rejecting it outright. But when we get down here, we do the warp, and then we do some quality checking. So we have our aligned. We get an aligned gray, just so we can do some quality checking, but then aligned is the thing we return if we succeed. So if we fail here, the only other return is this path. Gotcha. So instead, let us take a little extra time. Let's burn a little more fat. And yeah. This is what I need in my life. Okay. So now instead, what we will do is we'll push back reference. right. And we will push back aligned. And then we will average them. And that is what we'll do. So again, let's see what the old looks like. And then we'll compare it to the new and see how it looks. I do think okay, so that's running. Let's comment that out. We'll hit save there. And now this one we can run. While that's running, what? But I didn't. Huh, that's not what I wrote out. Did I do the wrong thing? I think I did the wrong thing. I must have done the wrong thing. To align. So we're either returning reference or we're returning aligned. Right? We're applying the transformation to aligned. And then when we're done, I have aligned frames here. I'm saying go average them. We'll get an averaged frame. Right? That's... I'm not missing something, am I? We did the average, and then we save our debug average. That's what I was doing. We called it averaged. In fact, I have one here called averaged. So if we're rejecting it, alignment quality low, that doesn't make any sense. Is it not building? Am I getting a build failure? This doesn't make, because this is still like the old. I am. So it didn't build. That's why we're going off of. Average frames not declared in the scope. I know why. Okay. Because average frames, the definition is down on 877. And then it's used down on 9. But I need it up at 240. So I need it up here. Fine. You can have it there. Please be happy now. And then where am I? Here? Okay. Let's get back to the test then. That succeeded, right? Cool. Let's run test here. need to pay attention to those build errors. Let's kill anything that's not the first test up until here. And if we're back here, okay, so now I can, well, yeah. That's the old, this is the new, and now we can run that. The other one finished. Let's go take a look at the first one. Show me what I want to see. Oh, well, now it says good alignment, of course. But alignment quality low. Okay, so this one. So this one says alignment quality is low, and I can see that that's pretty bad. Like it's pretty way off. So actually, let's do another folder. Test results, and this would be the one that just finished. Okay, so this one's also alignment quality low. And that's image 12. So that's bad. Crossing the chasm, crossing the chasm. This one, the second one is better. It does seem like the second one is better. Interesting. What about on our third image? This one said good alignment. Oh, but since it's good alignment, we don't spit anything out. Right. Okay, so what I should do is fix that. Okay, what are we at? Quick break. Think for a second. Okay, so 12:13. So this is the second one that ran. Too dissimilar, but 14 was alignment quality low as well. So that's the new one. This is the old one. Those seem about the same. So actually, it didn't seem like it had much of a difference at all. Interesting. At least not at the top anyway. The top line, they're both just equally bad. All right, so I don't have any discernible way of saying one's better than the other. Debugging issues when... Yeah, it's saying save the aligned one instead, so you can see what it's actually doing. Additional improvements. Gaussian pyramid. For better ECC coverage, consider using a multi-scale approach. Okay. Well, first off, let me do this. Where is that logic? Okay, here we go. I don't want to go too crazy here, but fine. Got to do what we got to do, right? So if and not, let's bring that down here, and then we'll do the same thing. We'll do the same operation. So if it says it's good alignment, then let's at least put out what the aligned images should look like for those two. Just for the two, right? So we can see them by themselves. That way when we're at a place where we've got multiple images that are good, but they're bad for different reasons, I can at least see kind of what's going on there. You shouldn't be here. You should be here. And then you all should tab in. Okay, there we go. So if we fail our check, then and we are doing writing debug images, then we'll do we'll do extra computation. And then same here, like regardless, if we make it all the way to the end, then we'll do the same computation so we can see what's going on. By the way, where is a line image used? So we have line image fast. For the heck of it, what if we did this? Line image fast. And then here, let's take this over down here. Right. We'll bring that up. And then also that quality check. Do we have the quality check here? Yes. No. Fix the, skip the final check. Quick rejection. But that's the translation too large, right? Yeah, we don't actually do the alignment. Okay, fine. That's good enough. Yeah, let's see if the faster version is actually also a better version. By the way, what I should do is have it so if it fails to build, we reject and we don't run the tests. I gotta fix that. Okay, that finished here, right? 1222? Yeah. So here we are. Comparing, and this is comparing just the vanilla old version that was supposedly better but slower. I thought it had good quality. Again, I think this test case is a bad test case. I think, you know, the book does move, but I do feel like in some of these, you know, again, in these good quality cases, either it shouldn't be aligned, like we should be rejecting it and not saying good things are bad, or not saying bad things are good, or we should actually be fixing the alignment. So this one says, this one failed final alignment. Image 12. This one in the fast version said it actually had good alignment. Who is telling the truth? So let's go to 195. Funny enough, I think they're identical. In this case, I do think it is an example of they're both equally bad. The difference is that the fast version doesn't do a final quality check, and so it doesn't reject it. Then we have good alignment and good alignment. Let's try to take it up to 200. So these both said good alignment. But it doesn't show the difference. Darn it. Okay, so the fast version, I don't know. I think that this looks like the same problem. So I don't think it matters which version. Both versions have this same bug. I half was hoping maybe the fast version somehow like actually got better because maybe it was doing a low quality comparison. That lower quality comparison was doing a better comparison kind of as a result. But I don't think it is. So, all right, let's get ourselves back up to this logic here. So it said that it thought warp inverse was going in the wrong direction. I don't think it was. For better ECC convergence, consider using a multi-scale approach. Did we have like a Gaussian blur? Let's take a look through these steps actually. So we compute grayscale, basic similarity check using statistical measures, so mean, standard deviation. Rejective images have vastly different characteristics. Brightness difference. See, I can probably, to speed this stuff up anyway, I could probably chuck things out. Because like the images, I'm like once I dial it in, the images are pretty much always going to be within a frame or two of each other. So I wouldn't expect large brightness differences unless maybe somebody turned on a light in the room like right before. So I don't know what the speed is of each of these steps, how slow they are. I mean, I can measure that, but I get the feeling like some of these early steps I could probably throw it out. Quick template matching check to verify images are similar enough. Okay. Initialize transformation matrix. Enhance ECC parameters for better convergence. So we try to do some things. Check our correlation coefficient. More warp matrix. Okay, I've tested warp inverse map and also the version without it. Not really seeing a difference. How would at what point in the steps would I apply Gaussian pyramid? I don't need the entire file, the entire code, just the line or two before and after the code change. Better initial transformation. If you have motion information from previous frames, initialize warp matrix with better starting estimate rather than identity. Okay. Adaptive thresholding. Consider making your quality threshold adaptive based on image characteristics or historical performance. Is likely the main fix for you. That would definitely cause good alignment frames to appear poorly. Okay. You'd apply it right before the ECC calls. Here's where to add it. This does a coarse alignment on half resolution images first, then uses that as an initialization for the full resolution alignment. The key is scaling the transformation component by 2x when moving from pyramid level to full resolution. Is that even a thing? I don't remember seeing that. Okay. So he has it down here, initializing the count, setting it as, okay. So Claude is saying, do it here. And then in the correlation coefficient, all right. Warp matrix. So you're saying to come in here like this. This gets our correlation coefficient, but where's the, and then the warp matrix gets initialized. Got you. Okay. For the moment, I'll keep this turned off. Or not. You know what? It didn't seem like it was the problem, so. Let's go back to test results. Here, let's run that. While that's running, I will pop out a level and keep an eye for build errors. Seemed fine. 1232. Okay, and then just because I still don't feel like I'm seeing what I want to see, let's test the second version as well. So in this one, so alignment quality low. We still reject it for good cause. This one said good alignment. But yet our alignment was pretty bad. This one's still building. This one also had bad alignment. And then, of course, when we average it, meh, you know. What about the other one? The new one. 34, right? Let's take a look. So if we compare these two, with the alignment quality low. Whoa, did I click on the wrong thing? Hold on. So this is the first one. And this is the second one. Again, I clicked on the wrong thing. Okay. This is definitely the second one. Okay. Wow, that's worse. So this one's better. The newer one's worse. This one said good alignment. This one said quality low. Again, I keep clicking on the wrong. Thank you, Microsoft, for having like black on black, so I can't even see where one window begins and the other one ends. All right, 13 good alignment, 13 low quality. Here, right? Okay. So that one said it was good. This one. See, this one is better aligned left to right. The one on the right is worse. So I am going to go ahead and say this is objectively better, the old way. And I shouldn't listen to the AI. Okay, and then let's do the doctor's office approach, right? So we've chosen this one to be better. Now let's flip the lenses and try again. So we'll do /star / and we'll bring back this version. So we do have these two mats initialized, but we don't use them. That's fine. And we just get our coalition coefficient. Okay. This is the new one, 3410, right? Yep. Okay, yeah. So we are building. We're not skipping. So now I'm curious. Again, this left was better. And it did a better job of aligning vertically. Well, I guess, yeah, horizontally aligning. And then what about the new? So if we do our quality low number 12, let's compare our number 12s. What are we at? Yeah, 146. Okay, fine. Okay. I see no real difference. Honestly, I'd say the old one's better. Ever so slightly. No, it's off by the word "the" in 2 lines. So, basically little to no effect. And then what about our good alignment friend? So that's 13 good alignment, and then we'll go to 160. I can kind of see a slight difference, but not really. Oops. Yeah. Okay. So no real effect. The Gaussian blur change seemed to have no effect. On closer inspection, actually was having a positive impact on aligning things left to right. The issue seems to be one image being lower or higher than the other. Thoughts? The problem is likely that ECC optimization can get stuck in local minima, especially with vertical translation. Here are a few targeted fixes. Better initialization for vertical offset. So initialize transformation matrix with better starting guess. I'll leave this commented out because it seems like it doesn't matter. And why have extra code and more complexity for something that doesn't seem to be adding any value? Okay, so it's saying, I mean, that's how we're initializing a work matrix. Try to detect initial vertical offset using phase correlation. Okay, and then we do the motion affin. Okay. Try detecting initial vertical offset using phase correlation. By the way, I didn't want to back out. I want to go here, which is 1232, right? 1232 is a couple of runs back, right? So that's my known good right now. So it's saying and then do a shift. Correlation coefficient gets initialized as a double. Criteria, what is criteria? All right, we don't mess with criteria here. Okay, so this is something that is just kind of happening on its own. So criteria is count, EPS, whatever. So this isn't going off of any variables. It's just initializing criteria. And then we convert to float. And then we compute a shift. And then we adjust our warp matrix. All right. Oops. Control Z. I'm willing to buy it. Let's bite. Old. New. Any build errors? $12.45. Yep, this is us. So 13 is our good alignment from the old one. Let's just focus in on that. And we'll go to 160. And how does 13 look here? Okay. That's annoying. Wow, that looks really good. That's like spot on. Holy heck. That's like exactly what I needed. Why is alignment quality low? It says alignment quality is low. What are you talking about? That is like perfect. All right, so on 13, alignment quality low. What's the deal? Here we go. Or try a multi-step approach. Step 1 seemed to result in a perfect result. In a perfect alignment. However, it was rejected with the following justification. Let's see. So down here, what was it? Final alignment quality too low. Yes, it was the final rejection. Normalization was not above 0.1. Yeah, actually MSE was quite low. I guess the question would be, given that it visually looks perfect, why wouldn't... Just want to understand, like, what does this actually mean? Be close to 0. The issue is that template matching is fundamentally different from image alignment quality. Here's why you're getting a low match score despite perfect visual alignment. Template matching finds the best matching location within an image. But when you're comparing two already aligned full images of the same size, it's essentially comparing them pixel by pixel at a single location. A score of 0.58 is actually quite good for this use case. Is excellent. That's what indicates perfect alignment. MSE closer to 0 means the images are nearly identical. If I go over here, the reverse, which is funny. So where's our image 13? Here we are. So correlation was 0.84. Final match was 0.62. Oh, my brain was in the opposite. We're not trying to get that to 0. So final alignment quality, I guess that's probably on a scale of 0 to 1. And the MSE has 2 zeros over here, but 3 zeros on the right. So it's just saying drop the threshold to 0.4 and normalize MSE to 0.01. So it's saying if I just do this, but better approach, rely more on MSE. Your MSE indicates that's exactly what you want. The template matching score is just not the right metric for this particular quality check. Okay, that's fine. Makes sense. Thank you. For further context, these images are still frames taken from video and would be frames that are very close from video and would all be from the same half second or less. time window. These images are also of open books where we have already cropped down to just the book itself using OpenCV. Do you see any adjustments to this code that might make sense for that scenario? Are there any wasted steps here that are unlikely to help for alignment in this niche case? Given your specific use case, cropped book pages from the same half-second window, here are some optimizations. Remove unnecessary steps. Remove basic similarity check. Unnecessary for same book within... Yeah, I thought so. Remove initial template matching. Also unnecessary. Optimize for book pages. Books have strong horizontal features, text lines. Enhance them. So... Simplify validation. All right, I am going to also, by the way, I kind of want to ditch this, but I think there are some things here I could harvest from it. By the way, let me do git checkout -b. Improve alignment. And then let's do a checkpoint here, since we know we've got something that's kind of working. Git add bin. What did I do? Star dot. Oh, GD, not GB. Alignment seems to be good for, I can't do exclamation points. If you do exclamation points, it like screws something up. I don't know why. You'd think it would escape everything in the code comment, but it doesn't. For one test case. And then let's go over to here. Go. Improve alignment. It's called frame alignment. Okay. And then, actually, so I made that change, but I didn't run it. Let's run it. So in theory now, we'll get this new thresholding where we'll actually get more than one image that it says are good aligned, are well aligned. So here's our template. Here was the new, right? So this one said alignment quality was bad. But that alignment quality looked pretty darn good to me. This one said alignment quality also was low. This one also had pretty good alignment. I mean, we can see down here, yeah, something, it's doing something right, I think. Too dissimilar, fine. Yeah, this one said alignment quality low. But, man, look at that. Look at that alignment there. So this is, yeah, so what did the score come back with? 56? Whew. Look at that. Okay, that's what I'm looking for. Nice. All right. Let's visually look at it. So yeah, now this is good alignment, good alignment, good alignment. So 3 of them are good alignments, right? When we average them all together, all 3, we get this. So we can see, like, there's some, you know, some data. Can we see that here? Not really, because of how I'm putting these images out right now. But I suspect that when we're done cropping, some of the images don't have the number up here. But look at that. So, and that's quite readable. I mean, if we compare that to our template, let's go up to like 214. So on the left here, like, this is a little blurry, to put it simply. This is the original. Now, actually, we're going to weigh this higher, again, because we still have that weighting issue. But, yeah, I mean, look at the word mainstream here. I think it's more readable. Like, the A is more distinct over here. It's hard to tell, but you work with words like prospects. That does look better. 2, the TO here is much better. Satisfy, I think, yeah, I think it's less, yeah, I don't know. It's kind of hard to tell, but I think it is better. And then when we get the final enhanced version, yeah, again, this is pretty bad up here, which I could tell already that was going to have problems. We must ensure that our first set, yeah, that looks pretty good. And then when we get the text translation, we must ensure that our completely satisfied there, ensure that, yeah. So I think in hindsight, we're going to find that a score of 56 is quite terrible. That's not like halfway there. Like, that is literally, like, it's probably order of magnitude change. Like, a score of 90 is probably half as good as a score of like 95. But at least we're in the ballpark again, finally. So I'll take it. I now know some things we can do. So good alignment frames aren't getting aligned properly. So let's throw out the frames that don't align. That'll help, because then that means we will weigh all the frames equally. Whereas right now, I think we're still having that problem where... So we have our template. We have 3 good alignments, actually. But then this 2 dissimilar one gets thrown out. And in its place, we use the template. So the template basically counts as double versus these other 3. In this case, I don't know how much it's going to help. But we will use more of its data. We'll use more data from this image than the others. So it can only help to throw those out. And then what else do we need to do here? Alignment related. Did the AI have any other suggestions? Right. So we can do our basic checking. We can skip those steps. By the way, like, yeah, so how long do some of these steps take in reality? I mean, it's hard to say, but if we look at it like successfully aligned images, successful, successful. Okay, so from here to here, I mean, it's kind of hard to see since we are running on a more powerful machine that can run these things so much quicker. And we're also saving off debug images, so... But what are we talking here? We're talking a 1.5 seconds. And then from here down below, what is it, 44 to like 45, 46, 47. Actually, that's more than 2 seconds. So this one took longer. So even on the faster machine, we're talking 5 to 6 to 7, 2.5 seconds. So we should try to optimize this. So yeah, basically saying skip this, which means we skip that. Let's go down to here. Okay, so saying skip those, and then the match template is not going to be necessary. Okay, so it's saying skip that too. So it's saying all those steps are not important. So then we get right into building a warp matrix and then doing the correlation coefficient. Yeah, this didn't help, so I'm just going to ditch it. And let's get rid of that. Optimize for book pages. So saying, so we do the grayscale ref enhanced, so we do some enhancement. Our warp matrix we initialize the same way, and then our initial criteria we change it to 1e to the -6th and 100. Translation only, since books rarely scale. Let's go with score of 56 now, right? So let's go with testing. I don't know why I did the autocomplete there. Test cases. And then $56 on align frames. There's our new. There's our new expected result right there. Okay. let's give it a go. I'm gonna stop soon for lunch. I'm getting hungry, but I just want to keep working on this because this is actually fun for me. So, okay, so that's that, and then fine. Let's bring this in up top. But where to use them? So this is going to do a gradient of some sort. Gotcha. And then we do inside the try statement, we're going to change this to use the different images. Right, we've swapped which images we use. So now we're doing some sort of initial change to them. Curious what that'll do. I'll leave this for the moment, but it does sound like we don't need to. Like, this check is unnecessary. He had already said that. So, it already auto-completed that for me. Yeah, all right, let's run this one. And we know our metric now is 56. For that test. I wonder if we get above 0 in the other one. Probably not. Actually, those images are so different, I wonder if it somehow like aligns them. Yeah, score of 11. We did terrible. Woof. This is the new good one, right? And this is the old one, where our alignment was terrible. Yeah, so we have a new A/B test. So you get rejected, and you are the new good one. This one back here. So this said good alignment. Whoa. That's cool. That's like one of those effects that you see. Oh, I'm getting dizzy just looking at it. Like it's like the room is spinning. Okay, so it did some sort of like twisting torsion thing. This one's fine. This one, again, the same. Like it's like some sort of like overly focused thing. And then the result is, I think we get some like words in the middle that are good, but on the fringes, yeah, it's horrible. All right, so you're the bad one. You're our good one. Huh. So what were those changes again? Well, we removed some validation, and then we did the whole like Sobol thing. Removing the validation just, I don't know, I guess that just speeds things up. That's all it's gonna do. Yeah, this is bad. Let's undo that. But we do want to clean things up a bit. So let's go ahead and rip out this. Interesting that you can't. Okay, so that simplified things ever so slightly. I do want to I do want to throw out those images, like throw away images that didn't help. Max translation. Only check for reasonable translations. Books don't move much. I'm not gonna waste my time with it. You know, this version works, so maybe I won't think too hard about things for the moment. Books don't rotate scale in a half second. I mean, I don't know, they could. Tighter translation limits, 5% versus 15%. Fewer ECC iterations, 100 versus 200. Did I make that change? Right. Let me... Yeah, this is the bad one. Okay. Let me rerun it again. Just to make sure that it wasn't like this code change, a correlation change. Because I think, what, if we do a git diff, commented out code, we removed some safety checks, but we did change the criteria. Okay, so it is possible that this newer stuff helped. Although I am seeing a bunch of results there. Where did we score at? 50. So our score dropped a little bit. But do we still, like, are we still mostly there? So this said good alignment. I can visually agree that the alignment's pretty good. This said good alignment. Also looks pretty good. Yeah, all these look pretty good. Although that's a little noisy there, maybe. Yeah, maybe the top isn't the best. But overall, other than the top and bottom, we're looking pretty good. All right, but the quality went down. So I don't want to berate this forever. So let's do that. Yeah. Okay. And I probably don't even have like a measurable boost in speed, do I? How much time do we take? 0.67 to... Whoa. That is like a third of a second. What about this one? This is a successful alignment, right? A third of a second? Like another third of a second. Whoa. So you mean to tell me that these like this extra checking, this like, is this where all the performance hit was up here? Really? I mean, I guess maybe this. You know, it could have been this right here. Yeah, okay. Don't be shocked if, like, this torpedoes it. Okay. One last thing before I drop off. Align image. So, great. One other change I'd like to make. Right now, we always return a mat. However, if things don't align properly, I want to throw away that frame and only use ones that successfully align. What change should I make for that? As reference, here is how I'm calling it. Would we just quote return for those bad scenarios and then catch the empty, then catch the null return? I'm guessing not. I think we have to return an image, a mat anyway, and we could return like an empty mat. And then if the mat returned is empty, then don't push it onto the array. Option 1, return empty mat and check for it. Yeah, okay, fine. Yeah. So aligned. Yeah, okay. So you're basically saying so you're saying do this. So we still do our alignment just like before with our frame off that index. If it's not empty, we align it. Otherwise, rejected, alignment failed. Cool. And then over here, what we would do, there we are. Anytime we have a return, we would just return an empty mat. I thought so. Yeah, you can't really like overload things or like just return nothing. Right. So in all these cases, just return empty. Right. So then our only return path is the successful one. Otherwise, we return empties. Okay. And we've reverted back to our 200 here. So if I run this now, I'm curious to see what the performance is, if it's faster. We may save a little bit of time by not trying to merge all the frames. So we might see that, but I don't think it would be that big of a boost, right? I don't think there's a lot of math involved with merging images together. But we should take a performance hit from this. Actually, really, this is the test, because the only change I made was returning empty and then these two changes. 52. I think our quality went up a bit. Quality was at like 54 or something. All right, so here we go. So we successfully align the first frame in 1.4 seconds. Okay, so instead of a third of a second, 1.4 seconds. And then 15 to 16 to 17. Interesting. That's frame... Right, frame 3. Yeah, it should be. Right, this is better logging. 15 to 16 to 17, almost 3 seconds. And then this one's basically 18 to 19, 20, 2 seconds. Wow, they all successfully aligned. To do. This is much faster, comma, but quality suffers. And again, the scenario I'm talking about, though, is both of these test cases, the images are bad, right? The alignment is quite terrible on them. And so I might be able to get by with the significantly faster version here most of the time. And if I did that, like, could we do this and then tighten the screws on some of the checking that we're doing and reject more aggressively? And just be in a place where, again, like, I'm fine, since we should be getting images pretty close together, there's not going to be much drift. And if we're able to shave 5 seconds off, and all we lose is, okay, instead of merging 5 images, we merge 4, like, that's going to be worth it. So I'll just put a note here for future investigation that this might be worth it if it doesn't really hurt quality. Like the final result quality. We did get a quality boost. I'm a little surprised that it was only 52. Let's go out and take a look. Oops, did I? Yeah, fine. It's okay. We're done anyway. Yeah, so they all ended up being good, good, good. When we averaged them out, we're doing a pretty good job of averaging. Although up here, it's looking pretty poor. Yeah, down here we've got some problems. It's not as good as before. I could make it a little, maybe it's got to be a little more sensitive on the rejection. That's probably why we're accepting everything, is we probably shouldn't. Like, one of these probably should get rejected. Like, yeah, like to be truly sales driven. Yeah, this first one's not as good, but obviously 13 is, we know, is a good one. And then 15, like this one's just, this one probably should get rejected. So it might just be as simple as being more aggressive on the rejection. By the way, what were those numbers anyway? I can see them. So where's our 13? 13's here. So it's the MSE here is 0.008. On the first one, 0.001. 3 was 0.0009. And then the fourth one was 0.001. So I could add like an extra 0 here. And if I run that, 52, like does that alone bump us up? All right, I do need to stop. I am quite hungry. But it's just so much fun tweaking things. Yep, so now we're rejecting some things. $72. Oh yeah. Nice. So this one is around, like, I think we did like 54 before, right? Not what I wanted. Go away. If we do cat testing, test cases, and then 56, right? And so we did lose some quality. We went down to 52. Bring this over here. So I did make some sort of change, clearly, that had some sort of regression in it. But now, yeah, see, like alignment quality too low. Because there's just a little bit too much noise in it. But these two had good alignment, and then this one also got rejected. So we weren't happy enough. And then when we average our frames, though, now we're averaging, well, what are we averaging? The template and the two middle ones, which honestly is what I would expect, right? I would expect 2 frames out maybe to have some quality issues, 2 frames ahead to have some quality issues, but the frames on either side of our template, because remember our template is actually in between these two, that those would do well. And, you know, still got some ugliness at the top here, but otherwise things are looking pretty good. And then what does the text look like? Is the text getting somewhat readable? I don't know. But our mathematical distance from here to where we're trying to get to is gone up. So testing, test cases. What is it, 72? And I can go look at what I changed and see if maybe there's another tweak I made that gets it, you know, another change I made that was a bad change that maybe gets us above 75. The other thing is, do we see in the logs here that, Yeah, okay. Rejected, alignment failed. So we are rejecting those frames. And then what is our speed? So if we start here till we get to there, so that's a 1.5 seconds. 18 to 1920. So that's like 2.5 seconds. 2.5 seconds. And then this one is a second. Yeah, it's okay. Before we go, let's do and we can do a skip here because we're not changing any code. Yeah, still scored 72 as expected. Still scored a 0. So we got better logging though, right? So whoa, that's our template for alignment? Oh, it just kind of squared it out. Yeah, that's a good crop, so that's good. That's our middle frame. Alignment failed, low correlation, alignment failed, low correlation. Okay, so I didn't know if maybe somehow we would have been able to. I mean, these all failed pretty early. Like, we didn't even get to alignment quality low, which is like that final check here. So it's not even like a thresholding issue there. It was just straight up, we rejected all of them at different stages. At the ECC alignment and low correlation. So where are those? So right up here. Yeah. Okay, so they got rejected pretty early. One thing I want to do is I want to go record another batch of 5 images using the new logic, because both of these test scenarios were from last week. Yeah, both of these test cases are older. Really? This says 7.3. I didn't touch it. Maybe because it got re-imported. Huh. I didn't rename it, did I? I don't remember doing any of that. Anyway, yeah, these are both from like last week. So I should record a new one where I actually get more realistic frames based on the new logic and run that through this. I would expect actually that we may even score higher than this. Yeah. All right. Anyway, I have taken enough time. Thank you for hanging out with me. We got this done. And the question is, merging multiple frames, what else is there? I may, I guess I'll probably experiment with a couple of other improvements later today, maybe. But I think this goes to bed. This one's done. And then, actually, if we look at our tasks for today, I'm going to say we fixed the alignment regression. Like, we're basically there. Yeah, so the final bit would be just add dskew. Test some ordering. Test rearranging step order. Right? So what happens if we, deskew before, before doing alignment, right? What happens if we do alignment later, right? In some cases, maybe, again, we boost performance, but we reduce speed because now instead of rejecting low quality images, like we're doing all these extra steps like deskewing them, and then we try and then we detect that their alignment's terrible. So yeah. So anyway, try to de-warp, deskew, test arrangement, and then be done. So I think one way or another, I think I'm going to be done. Because I do think it's going to be real quick to do things like deskew. There's some other basic OpenCV enhancements I can do. And then I think we're going to get good alignment. Yeah. All right. Well, that's it. Thank you for hanging out, and we will chat again soon, probably on Monday. I doubt I will stream again. All right. Talk later.